Hey there everybody, welcome to the next data analysis video of the course. In this video I want to introduce the concept of a data frame for you in pandas and then show you some basic data analysis commands you can do with pandas. So the point of this video is to show you how pandas, the library, stores data, how pandas sort of thinks about spreadsheets, and then show you some of the basic data analysis tools that pandas has. It has lots of nice built-in functions, as I mentioned in the previous video. In this video, I want to show you some of those nice built-in functions. Okay, so the point of today is to get you comfortable with the basic data format of pandas, and it's called a data frame, one word. A data frame is essentially just a spreadsheet or a table, right? A table you can also think of as a spreadsheet. You just have multiple rows and multiple columns, and the columns have names. The rows also sometimes have names. So a data frame, from the perspective of pandas, it basically just is a spreadsheet, but it's a spreadsheet that's been processed and eaten and now formatted in such a way that the program can easily handle it. So almost always a data frame is created by tossing the program a CSV file or an actual spreadsheet, right? Like a file with a bunch of data in it. Pandas eats in that file as a data frame, and the data frame becomes that spreadsheet but inside your program. It's now internal to your program, and you can start smacking it with pandas commands. Almost always, that's what we'll be doing. So almost always, we'll just have too much data to not be in a file, right? So you have a bunch of data in a file, you want to eat it in. For this video, though, I'm just going to show you how you can build a data frame from scratch within the code, just so we have a very, very small amount of data, so it's clear what these pandas commands are doing. So again, what I'm doing today is just sort of a toy example of data. This isn't something you would do in practice. You would never build your own data frame by hand, by hard coding it in. But that's what I'll show you how to do today. So suppose this is your data. This is a tiny spreadsheet, okay? 2 columns and what? If you include name and age as a row, right? There's only 8 rows. So how could you tell pandas, hey, here's my spreadsheet, man, and tell pandas to save this as a data frame? Let me just show you how that works in Jupyter Lab. I want to keep that here so I can reference it. Okay, so here's Jupyter Lab. Here's a blank Jupyter Labs notebook. If you want to use pandas in Jupyter Lab, you always have to start your code with this command: import pandas as PD. So the import pandas part lets us plug into the pandas library, and PD just shortens the word pandas to PD, so that in subsequent code, I don't have to type the word pandas every time. I can just type PD. Now I'm going to run this cell, or this panel. I should say real quick that I don't click the run button here, this play button. On your keyboard, if you just hold shift and enter down together, it will run. So I'm going to do that. I'm going to hold shift and enter down. And now notice here this little star. It was only there for a second. That was telling you that it was doing your command. So it took it a second or two to actually run this. Sometimes it can take it a while to plug into these large libraries. So now, as was the case in the previous video, this panel or this cell has been run. It was the first cell run. That's why that 1 is there. And now we can use pandas, the library, and any subsequent cell, any subsequent panel of code will know that pandas is there. Okay, so now I have my spreadsheet of data over here. Sorry if this is small, but there are, 7 names, and then 7 age numbers, and 2 column names. So how do I tell pandas, hey man, that's my spreadsheet? Well, first you can create just a little, you can create that data as a table like this. So this name here, I'm calling it data. You can call it whatever you want, but you basically have to build this spreadsheet by hand if that's how you want to do it. So I have to tell Python that I have a column named name, I have another column named age, and then I have to tell it all the individual entries. So here's how I do that. I say, hey Python, first column is named name. And what's in that column? What's in that column is a list of names like this: David, comma, Lori, comma. So you just keep typing Kim, comma, what's next? Alex, comma, and so on. You just keep building like this: David, comma. So it's David, Taylor, David. So let me bring this over here. David, Taylor, Taylor, You can use double quotes, but I like to keep it consistent. Single quotes, and then there was a final David at the end. Okay, and then I close that brace off there. So there's my first column. The column is named name with a capital N, and then these are the individual entries in that column. Now I just put a comma here, and then I can build the next column. And that next column is called age. So now I do the same thing, put age in quotes, that's its name, colon, and now I just put in the list of ages, the same way I did with names. So 19, 20, 20, whatever, right? So let me just do that. These don't have to be in quotes because they're numbers, 19, 20, 20, 21, 18, 18, 16. Okay, so I've basically handed it 2 columns, and now I close that brace there. So sorry, I don't know why it's not letting you look at the entire thing. But let me go back to the beginning here. I'm creating a table called data. And again, you can call this whatever you want. You can call it my table or whatever. So the curly brace here opens the table, and the curly brace at the end closes it. And then inside of it, you just tell it, hey, I got a column named name, and that column consists of a list of these names here. I put them in quotes because they are strings, you know. Then when that list is over, comma, here's the next column named age, and then you tell it the age data. Okay, so once that's over, this is not a data frame. This is just like an internal little table inside the program. The way you turn this data into a data frame is with a command like this. df, you can call this whatever you want. I'm using df just as short for data frame. On the right hand side though, you can't do whatever you want. PD for pandas, dot, data frame. The D is capitalized, the F is capitalized. And what do you want to make into a data frame? What you want to make into a data frame is that thing called data up above. Okay, so data is like an internal table that's not a data frame. Then you take this little internal table, hand it off to pandas so that pandas processes it as a data frame. And once you do that, you can then plug into all these nice little pre-existing commands that pandas has for data frames. So I'm going to run this by hitting Shift Enter, and notice there's a 2 now. It ran it. Okay. So now that you have this data frame in there, you can start doing things with it. So let me just show you real quick the kinds of commands that we'll do. Make this big again. You can do things like print. There's a command called .head. I'll show you. You can pick off a given column, pick off a given row. You can describe the data and so on. I put this horizontal line in here because I'm going to split this video in 2 just to keep things digestible. So I'll show you these 5 commands now, and then the next video will show you these 6 commands. There's just all sorts of nice little things you can do with data like this. So I'm going to show you these 5 right now. Print, head, getting a column, getting a row, and that .describe command. Okay, so the first thing to point out is that you can, of course, print things still in JupyterLab. So I can do a command like this, print df. I'm going to run that cell, and below it, what does it show me? It shows me that table. Here's my column named name, here's my column named age, and there's the data. Notice it also includes row numbers. So it starts its indexing at 0, as Python will do. So row 0 consists of a name David, whose age is 19, and so on. So you can print things. Let me just point out real quick that in JupyterLab, you actually don't need to even include the word print. You can just do this. You can just literally type df. And if you do that, Python knows that when you hit run, it knows that you want it to display that. So again, it just shows me the same thing. Shows it to me a little nicer on some level, right? Because I didn't use that print. So anyway, you can still print things, but it's almost better not to even say the word print. You can just tell it, hey, this thing here, man, here it is. And it knows you want it to show it to you. It knows that you want it to print it. Okay, so that's the first thing you can do. Let me show you this .head command. Okay, so if I do df.head, and suppose the parentheses are empty first. Let me run this and show you what it does. If you do .head like this with empty parenthesis, no matter what your data frame is, no matter how big it is, what JupyterLab will show you are the first 5 rows. Notice that's what's here, right? Row 0 through row 4. So if you just do .head, it just shows you like the top of the data. If you put a number in here, like say 3, that 3 is just the number of rows it will show you. So here's the first 3 rows. If you like a 6, right, it shows you the first 6 rows, whatever. Okay, so notice, here's another nice thing about JupyterLab. I can just tweak things inside this cell and just rerun the same cell. And now that 7 there tells me like I've been running the cell a bunch of times, because here's the second cell that got run. So runs 3 through 7 must all have occurred inside this, this cell right here. So anyway, you can control how much data it shows you with this .head command, and you can tell it how many rows you want it to show you by putting a number in there. Okay, so next, picking off a given column. So this data frame has 2 columns, a name column and an age column. Suppose you only care about the name column. You can do a command like this. Create another data frame called DataFrame2, or again, you can call these whatever you want, and you go like this, df. If you want to access a column, you just need to know its name. So there's a column literally named name. So I do df and then square bracket notation, name. And then once I've done that, I'll ask it to show me df2. And what does it show me? It shows me just that name column, right? So df2 is a data frame that was sort of sliced off of df, right? Just the name data. I could also, of course, get the age column if I want to. There are the ages, right? So all that to say, if you have a data frame with a bunch of columns, you can just pick off a given column. If you want to, all you need to know is the name of the column. What if you want to pick off a given row? You can do that also. I should say that this might not be so useful for us. However, it might become useful depending on what we want to do with, say, COVID-19 data, which I haven't completely decided yet what we're going to do with that. But anyway, if you want to pick off a row, you use a command like this, df.loc. Loc is short for location. And then you have to tell it which row number you're talking about. Okay, so this is row 0 inside data frame F. Okay, so the first row was what? First row consisted of David, or sorry, row 0, right? It starts counting as 0. The 0th row consisted of the name David and the age 19, and that's what it tells me is there, right? What about row position 2? It tells me it's Kim and age 20, and that's what's there. So anyway, if you want to sort of like navigate around a table like this, a data frame like this, you can look inside a given row, you can pick off a given column if you want to. The last command for this video is the .describe. This is really nice. This is the kind of command that you want to do for any sort of data analysis that you'd like just to be built in and not have to think about yourself. Okay, so let me just do this. df.describe. I have a data frame built. .describe. It's just going to like print some information for me. Okay, it's going to like describe that data frame for me. And notice it tells me a count, so it's telling me there are 7 things in there, 7 rows. It tells me an average, a standard deviation, a min, and a max. So what? The minimum age was 16, the max was 21. Depending on how many columns you have and how much information you have, describing the entire data frame might not be so useful because it might just spit a ton of stuff out here you might not be able to see. Because again, imagine your data frame has like, I don't know, 200 columns in it. There's like an age and also a numeric letter, a numeric grade, and also their student ID number or whatever, right? So you might not want to like get all the description here. You might just want to describe individual columns, say. So like, what if you just wanted to describe only the age column? You could do that like this. So again, without the .describe, we've already seen this, right? This is just the age column. This is how you pluck off a given column. So you can pluck off a given column and ask JupyterLab to describe it to you. And it, again, tells me like basically the same information, right? Because when I did .describe on the DF, it assumed I wanted the numeric description of the numeric data, right? This data frame has both non-numeric and numeric information, names and ages, a statistical description, right? These are basic statistics here, right? It assumed I wanted age. So again, it tells me there are 7 ages. The average age is 18.85, whatever. The standard deviation was 1.676, whatever, so on. You can also, of course, ask it to describe the other column, ask it to describe the name column. Just real quick before I run this, what it's going to describe for me should look different from this. The name column consists of non-numeric data, consists of names. So there's no such thing as an average of the names or the standard deviation of the names. Python knows this though. Python knows that these are not numbers, so it will just give me what it thinks are meaningful descriptions of that kind of data. And it tells me there are 7 of them. There are 5 unique ones. So in case I want to know how many unique names I have in this class or whatever, it tells me there are 5 different names. 7 total though, when you account for repetitions. The most popular name is David, and there were 3 of them. So it knows that this is not numeric, so it tells me what it thinks I might want to know about that kind of data. Okay, so we're going to pick this back up in sort of video B of this material, but hopefully even just seeing this .describe thing lets you show you some of the power of feeding a spreadsheet into a data frame, right? It just has these nice little simple commands to just kind of tell you things that it thinks you want to know. So we'll pick things back up in the next video.